very much.
Yep.
All right. I have the distinct pleasure of being between you and dinner. So I'll try to be interesting and hopefully relatively brief. I'm disappointed that the fourth presentation, I was looking forward to that one. So I guess I get some time, but I don't get that information. So thank you very much for having me here today. So Tool Design Group was fortunate enough to work on this 2-year project with the Michigan Department of Transportation. We also worked with Wayne State University as a subconsultant. They helped us specifically with the crash analysis that we worked on. So just a little bit about myself. I've noticed that so far only the consultants have felt compelled to introduce themselves. I am a traffic engineer. I work with Tool Design Group out of our Minneapolis office. I'm originally from Minnesota, went to Michigan State University for 2 degrees, lived in Detroit for about 7 years, and then 4 years ago moved back to Minneapolis to work for Tool Design Group. So I know the folks that worked on the Milwaukee study that we talked about earlier. So just a little bit of a background to kind of frame the conversation. Sidepath is a type of shared use path located parallel to the roadway. So that's really important. We have some design guidance for shared use paths in general, but those can sometimes be trails through the woods or places where you might not encounter vehicles at all. So what's important to know about side paths, like in this example image here, is that they are parallel and adjacent to the roadway. So the people on the side path are going to interact with turning motor vehicles. They are typically bidirectional, so bicyclists are going to ride in both directions along the side path. There's a couple of reasons for that we'll get into in a little bit. And then they are usually separated from the roadway with some type of buffer. So there's a little bit of a landscaping buffer here. Occasionally, if there's a width restriction, the side path could be right behind the curb. So side paths offer a really great compromise in providing bicycle infrastructure, specifically in a suburban condition. One of the things that we find is on maybe a roadway that was originally a rural 2-lane cross-section that then, as the suburbs developed, became a much more traveled path, may not have included a curb and gutter and sidewalk as it was developed. So as agencies are going in to try to retrofit and include bike and pedestrian infrastructure in their corridors, side paths are one really efficient way to do it. So they're typically about 10 feet wide, and they're typically only on one side of the roadway. Bicyclists, we know, tend to find bikeways that are separated from motor vehicles to be more comfortable. That gets into that bicyclist level of traffic stress. But engineers have some concerns about safety on side paths. We've had some instruction over the years to people to not ride their bicycles on sidewalks, and how are side paths and sidewalks different. So this project was focused on researching what best practices related to side paths, and then also doing some crash analysis specific to them. There's actually not a lot of information out there related to side path safety, and there wasn't any in Michigan yet. There is a study out of Florida where they found that 7-foot wide side path or wider tended to be the safest design for side path. And then if the roadway speed was 45 miles an hour or more, having additional buffer space for the side path increased safety as well. But that's about all we know, and really kind of nothing related to intersections or crossings. So there were a number of different tasks associated with this. Sort of the two big focuses are understanding how Michigan residents sort of feel about biking in general, and then also side paths in specific, and then research to understand bicycle crash characteristics along side paths, which we were then hoping could lead into some design guidance for practitioners here in Michigan. So here's kind of the outline of the sort of the 4 key efforts in this project that we're going to talk about. I mentioned that I only have 2 degrees from Michigan State. I definitely was not the one doing the crash statistics on this project, so I'm going to talk through the crash analysis to the best of my ability, and then get into some of the other materials as well. So the crash analysis methodology, we had 3 different components. We did a statewide analysis, just kind of a general descriptive statistics about what was going on in the state of Michigan, and then also to sort of focus in on where we wanted to look. We attempted a case control analysis to pair up, I think it was about 110 case sites with 110 control sites. I'll talk in a minute about how that didn't quite work out. And so then we went into an in-depth multivariate analysis for 2 high crash counties in the state. So there were 2 counties where we found that there were a lot of side paths that had been constructed, and so therefore there were people that were involved in crashes on those side paths. One of the really interesting pieces of information very early on in the study, as we were talking about what the difference between a side path and a sidewalk is, I just mentioned that it is in the roadway right-of-way and it is parallel to the road. So side path tends to be about 10 feet, tends to be asphalt, but there are cases where a side path might be 6 feet or might be concrete. Sidewalk could be 10 feet, so it was really challenging looking at the data just without physically going out into the field and sort of taking a survey of several engineers, whether it was a side path or a sidewalk. So we lumped them together in this analysis. So I'll have some stats later that'll say sidewalk/side path, and that would be why. Exposure was the other big issue that we had with this. I cannot express enough the value in taking data collection for bicyclists and pedestrians in every community. Not knowing how many people were biking on the side path made it very challenging for us to draw some conclusions about the numbers of crashes that we saw in particular locations. So we had 11,305 statewide crashes over the 6 years of data that we were looking at. Data collection efforts included statewide crash records, police reports, and GPS locations of the crashes so that we could look in detail into the roadway geometry. We did a lot of detail on the geometry for when we were trying to do that case control. We also assigned each crash a 3-digit code described by the Pedestrian and Bicycle Crash Analysis Tool, PBCAT. If you go to pedbikeinfo.org, I think you can find, it's a really interesting tool. This is just like an example of one of the high quality graphics that they produce, but they categorize pedestrian or bicyclist involved crashes into subcategories that are a lot more specific than what you might find on a state police crash report. So with the case control, we initially attempted to pair 110 crash locations with 110 case control locations. The control sites were just really hard to find. We were hoping to find patterns of similarity between the geometric characteristics of the case sites and the control sites. Lots of our case sites actually only had one crash. And so we ended up putting a lot of weight on what happened in one crash instance. And that just really, from a statistical standpoint, didn't really work out. So version 2, we focused in on Oakland and Kent counties. These are 2 counties in Michigan that have implemented a lot of side paths, especially Oakland County, kind of doing that arterial roadway retrofit. They've really adopted side paths. We also wanted to get sort of both sides of the state, recognizing that Southeast and Western Michigan are going to have some different behavioral issues. And so we had a total of 2,200 crashes between those 2 states, or between those 2 counties to look at. So one of the interesting things that we found, and because we don't have exposure information, these are just sort of high-level descriptive statistics. If the bicyclist was riding on a sidewalk or side path, their injury or fatality rate was only about 5%. If they were riding in the roadway, their injury or fatality rate was about 14%. So we definitely saw, as we talked to bicyclists about what their preferences were, they preferred to be separated from traffic. There was a reason that they preferred to be separated from traffic. It ended up being less detrimental for them. One of the other interesting things that came out of this analysis was with respect to low volume roadways. And so for low volume, these are very, very low volume. These are crossings of the side path where ADT is not even collected. So our lowest ADT collection value, I think, is 5,000 vehicles per day. So these are, we're talking about like residential driveways or, driveways into shopping strips, that kind of thing. So overall, bicyclist crashes at low volume roadways accounted for 43% of the crashes that we looked at. If the bicyclist was on a side path or a sidewalk, then those low volume crashes accounted for 46% of the bicycle crashes. One of the reasons for this probably is that there are more low volume crossings than there are the medium or high volume crossings. So if you think about your functional classification of roadways at your local road level, you have lots of access points, so there's just more places for this to happen, and that could be why that percentage was higher. So when we looked at the PBCAT categories, there were sort of two motorist involved categories that kind of jumped out. This first one is what they called a motorist drive out. So a motorist is coming out into the space where the bicyclist is, either at a stop sign or at a signal controlled intersection. And then the other one was motorists turning left from the opposite direction. Especially, and so the PBCAT graphics aren't quite showing our side path situation, but if you think about turning left into a driveway, especially if you're maybe on a 4 or 5 lane roadway, you've got a lot that you're looking at, that you're paying attention to as a driver, and so ending up colliding with a bicyclist is can be, I guess, no, I don't want it to be expected, but okay, so this finding about the bicycle direction of travel also kind of helps tell the story about why the case control maybe didn't work quite as well. So if the bicyclist on the side path or sidewalk was traveling with traffic, that accounted for 31% of the crashes. The balance of that is if the bicyclist is traveling against traffic, 65% of the crashes in that case. Those don't quite add up to 100. I think the other 4% is we just couldn't identify the direction of travel. So when a bicyclist is traveling against traffic on a side path, they are more likely to be involved in a crash than if they're traveling with traffic. And so as we kind of worked into our design guidance for this project, we had a lot of conversations about what that meant. So is there a way that we could design a side path to encourage bicyclists to ride with traffic instead of against traffic? And our general conclusion was actually no. Side paths tend to exist in locations where crossing the major roadway can be challenging. And so even if there was a 6-foot side path on either side of the roadway, would bicyclists actually go to the trouble to cross the roadway to ride with traffic, or would they just continue to ride against traffic as well? Also recognizing that sometimes from a right-of-way availability standpoint, you might not have the space to put something on both sides, and then also looking at where destinations are. If crossing the roadway is challenging, are you really going to cross, come down, and then cross back again if you are currently on the same side of the road as your destination? So from a larger bike and pedestrian planning perspective, we didn't want to suggest that two-way facilities should not be built. Instead, we worked towards what types of recommendations could be made to make those crossings of two-way facilities safer. So two of the options that we found, specifically with respect to signage, one of these is from the Colorado Department of Transportation, one is from the Virginia Department of Transportation. I should mention that both of these signs are experimental and are not currently MUTCD compliant, but I'm actually a really big fan of, this is they've repurposed the railroad crossing sign. So this is, in the MUTCD, this is actually a railroad track right now. We looked at a lot of different ways to try to communicate to drivers that people could be biking in both directions parallel to them. And this sign really, I think, got the job done. And then watch for turning vehicles. This would be a sign that we would show to bicyclists to help make them aware of the risk. So the other sort of big research aspect of this project was a residential survey. This is a random survey of about 5,000 Michigan residents. We wrote a letter in English and Spanish and mailed it to a random sample of addresses across Michigan. We had a pretty good response rate. We had about 7% response rate for that randomly mailed survey. I think there's a couple of reasons for that. One of the reasons is that a group of graduate students from Wayne State hand addressed the envelopes. We also had them put first-class stamps on them instead of doing bulk mailing rates. Hand-addressed and hand-stamped letters were more likely to be opened. We also sent this, what I consider to be attractive, postcard to follow up on the letter that we sent in order to encourage people to respond. We asked that only one person per household respond, and we offered a $5 gourmet coffee gift card. I'll let you decide what gourmet coffee restaurant that might be from, which were privately donated and acted as an incentive. So the Michigan DOT wasn't able to provide a financial incentive for the survey, but we were able to make that happen, which I think really helped kind of drive the responses quite a bit. We didn't have any responses to our Spanish language survey, which was a pretty big task to get the survey into Spanish, but we felt like we really needed to try to, especially because one of our focus research areas was Western Michigan. We felt like we needed to at least make an attempt to do that. I will tell you that people are really motivated by a $5 gift card. We had a couple of folks very early who had a little bit of, technical issue with the survey who were emailing us and calling us, and it was great. I mean, we wanted their responses, but it's $5. So and the other thing we did actually with the survey is, so we did this random mailed sample because we didn't want a population that was self-selecting to take the survey. Simultaneously, we went ahead and did publish it online. We had some bicyclist groups sort of push it out for us. And we found that the online group did self-select towards bicyclists a little bit. We wanted to talk specifically to drivers who weren't bicyclists, so we were glad we did the mail survey. And the people that received the survey from an online venue, their opinions tended to be stronger, either one way or the other. They had stronger opinions than the people who were answering the mailed survey. So maybe there's something about finding out about a survey on Twitter that just makes you feel more strongly about whatever it is you want to tell us. So the other really kind of interesting aspect of the resident survey is the images that we used to ask people how they felt about different types of bike facilities. So these particular images are the same images that were used in the NCHRP 08102 study, so that then we could compare the results from this to that directly. The images look really boring, but we wanted them to be in black and white, and we wanted them to be as consistent as possible so that we could really get people's response to the bicyclist position on the roadway. So like this car is exactly the same, it's actually the same bicyclist. We spent a lot of energy making sure that these were just right. Participants were also asked about near misses that they experienced either as a bicyclist or as a driver. As someone who's been biking for over a decade, the near misses that I have experienced have really kind of dictated how I ride. I've been lucky enough to not be involved in a crash that has resulted in a crash report, so we found this information to be really valuable. It turns out that people who identified as frequent cyclists also indicated that they liked biking. So that's good. Oddly, people who indicated themselves as never cyclists did also tend to indicate that they like biking. So, that maybe they like biking, but they just haven't found the occasion to work that into their lives. So maybe we can provide that for them. Getting regular exercise was important to people. I like the idea of sometimes walking or biking instead of taking the car. So we're really trying to kind of zero in on people who are in that what we call interested but concerned group. So there's a large portion of the population who could be interested in biking, but there's something that's holding them back. And so this helped to kind of identify this. People who identified as frequent cyclists would like to see more people biking in their city. They recognize that safety in numbers. They would like for there to be more people out there with them. People who identified as never cyclists, 30% of them were also open to seeing more people biking in their community. So, recognizing that there may be some benefit overall. This is, as someone who works in separated bikeway design, these are not shocking results, but these are what would encourage you to bicycle more. And so I think we had people pick the top 3 or the top 5, which is why these numbers are adding up to more than 100. But separated bike facilities, which we had shown them what that was, 75% of the people responding indicated that would encourage them to bike more. On the low end of the chart, easy access to bike safety education. So folks may, and I'm interpolating a little bit here, but folks probably felt like they already knew how to bike safely, and that was not, they didn't need the education, they really just kind of wanted the infrastructure. Law enforcement of motorist behavior scored a little bit better than law enforcement of cyclist behavior. So, knowing that people generally wanted separated facilities, knowing that we had this issue with two-way bike travel, but that also it was probably unavoidable, initially that we wanted a facility selection type tool where you could say, okay, here are the characteristics of my roadway. Should I build a side path or not? And what should it look like? But when you could look back to the crash analysis, it was more behavioral issues that really were the indicators in the crashes, and so we sort of took a different direction with the design guidance. So instead, we focused on intersection treatments that could be used in order to address those situations. So the date on the cover of this is actually May 2018, but we are on the verge of having this thing published. The Sidepath Intersection and Crossing Treatment Guide tried for a less of a mouthful of a title, but didn't quite work out. So this guide, which will be available on the MDOT website in the very near future, includes a process and some guidance for integrating high-quality bikeways into a proposed project or as a standalone project. So we've got some guidance on sort of bikeway selection in general, and then safety considerations for side paths and intersection treatments to try to address that. So this is just a little snapshot of kind of what that process looks like, knowing that we're targeting practitioners in Michigan, we're probably targeting engineers. The first couple of steps, if you're a planner, you recognize as key planning steps. One of the things we found over the years working in design across the country is that, if you give an engineer a roadway design, we give them a bikeway design project, they jump right in on what the lane width should be. And so asking them to kind of take a step back and look at the existing bicycle network, that could be a very good indicator of if you are doing a side path on one side of the roadway, what side should you do? Existing crash history, if there is one. Then into engineering the actual side path. And then step 7 here is where the intersection treatment guidance really kind of comes in. So the guide has sort of based on the type of crossing, just some suggestions for treatments, and these treatments are all described in detail before we get into the tables. So in this case, these are suggestions for a signalized intersection versus for suggestions for an unsignalized intersection. We get into those low volume driveways as well. So recommendations for signalization, raising the crossing, curb radii to reduce the speed of the vehicles coming around. This offset distance, this is something that there is research on this suggesting that between 6 and 16 feet of offset can help the driver to start the turn and then notice the side path. So it's sort of two separate interactions instead of trying to do everything at once. Signage, we mentioned the signage from Colorado, there's also this particular sign here is the R10-15. It is an MUTCD sign. It's technically only supposed to be used at signalized intersections. We've seen it used at unsignalized intersections, so some options there. And then pavement marking stripings to call attention to the crossing. The guide also includes a fillable form of a worksheet. So this is just sort of checking off the steps that you've taken the steps, maybe making some notes on what you found. You know, one of the things as we move forward with improving intersection designs across Michigan is we want to know what some of the barriers might have been for the designer as they've attempted to do this. So maybe not all of the recommendations from the guide get implemented. We want to know sort of what got in the way. And then finally, the last task in this was the development of some educational materials. So knowing what our crash types are, that we've got turning vehicles and we've got bicyclists riding against traffic, what kind of advice can we give to designers and to the public? We've developed a script for a video that I think MDOT may be producing in the next 6 months or so. So it'll be a little bit after our contract is over, but just providing some of the information that I just shared with you in significantly more than 3 minutes, in 3 minutes for general consumption. The other I find exciting piece is these info sheets. So the website for this project will have these one-page informational sheets. We've shown we've developed sort of a artificial Sidepath intersection to show what the common crash types are in a way that we're hoping the general public, folks that don't have statistics degrees, can understand. We've got some guides for bicycling on side paths and some guidance for driving near side paths. As a bicyclist, I really wanted to focus on the driving instruction and less on the bicyclist instruction. We ended up doing both. And then just over the overall benefits of side paths. So that one is results from that survey where we found that folks really did want more separation. And then a one-page kind of advertisement for the design guide that we developed. So sort of takeaways from the project, data collection for bicyclist volumes on side paths is going to be really critical to addressing exposure issues in the data and understanding crash trends. People strongly prefer separated facilities. Building more separated facilities in a connected network will help encourage people to bicycle more. Contraflow bicycling increases crash risk along side paths, but we would like to recommend treatments to address that risk rather than trying to dissuade people from riding against traffic. So, all right, it's a little past, but I am happy to answer any questions.